So now we're discussing about the problems on current electricity. There is exercise 2, question number 42. The internal resistance of 2.1 volts cell which gives a current of 0.2 ampere through a resistance of 10 ohms. Now what is given by the internal resistance? What we can find the internal resistance? We can find the cell of EMF, that is E is equal is given 2.1 volt, which is give the current. The current is given I is equal to 0.2 ampere through a resistance R is equal to 10 ohms. It is nothing but this is the battery of EMF and it is the external resistance and connected by this one. The carrying of the current is I and the resistance and cell of EMF E, positive and negative terminal, and its internal resistance is the small r. Now what is the formula is there? We know the formula for the total current is equal to total EMF by total resistance. Now write here the total EMF. Total EMF how much is given by the other 2.1. Total resistance, external resistance plus internal resistance, that is a capital R plus small r is equal to current. Then the cross multiplication, capital R plus small r is equal to 2.1 by current. That is equal, we can write the small r, we can find the 2.1 into current minus capital R. That is equal to 2.1 by current. Current is equal to how much is given by the area? 0.2 minus external resistance. External resistance how much is the area? 10. Now the cross multiplication. Then the cross multiplication, what is the area? The 2.1 minus 10 into 0.2. That is a 2 by 0.2. So that is a 0.1 by 0.2. So that is equal to 1 by 2. That is the 0.5 ohms. Internal resistance how much is the area? 0.5 ohms. So next, see the question number 43. Question number 43. The EMF of a diennial cell 1.08 volts when the terminal of the cell are connected to a resistance of 3 ohms. The potential difference across the terminals is found to be 0.6 volts. Then internal resistance of a cell. Again, what we can find in this condition also, we can find out the internal resistance. Now we are given by the EMF of the diennial cell. The EMF of the means E is equal to 1.08 volt is given by that. When the terminal of the cell are connected to the resistance, the R is equal is given 3 ohms. The potential difference of the terminal P is equal is given 0.6 volts. Then find out the internal resistance. But here is not given by the current. Again, using the current is equal to total EMF by total resistance. External resistance plus internal resistance. From Ohm's law. What is the V is equal to I into R. Then I is equal to V by R. What is the V is equal? I is equal to V by R. See this I value, the substitute here. See what is the V by R is equal to E by capital R plus small r. Then the cross multiplication this will be. See V into capital R plus small r is equal to E into R. Then the multiply here V into capital R plus V into small r is equal to E into capital R. Now this VR is taken this side. The V into small r is equal to E into capital R minus V into R. Then the small r is equal to E minus V into capital R by V. So this is the formula for the internal. Then its values can be substituted. The small r is equal to E is equal to how much is there? 1.08 minus V is equal to how much is there? 0.6 into external resistance is the 3 ohms. The volt by 0.6. Then we are the calculation. The getting of the value is there 2.4 ohms. Next, see the question number 44. A primary cell has an EMF of 1.5 volt. When the short circuit, it gives a current of 3 amperes. Then internal resistance of the cell. See what is the primary cell? So this is the primary cell. Now its EMF is given by the 1.5 volts, is connected to the short circuit. Short, okay, what is here the short circuit? The short circuit means there is no internal resistance, that external resistance become equal to 0. And it's given by the internal resistance. That current is given by the flowing of the current. Current is equal to 3 ampere. Then find out its internal resistance. Again the formula, what is it? I is equal to E by R plus small r. Then I is equal to E by the external resistance is 0 because of it is a short circuit. Then substitute here the values. The small r is equal to E by I, that is equal to 1.5 divided by 3, that is equal to 1 by 2, that is equal to 0.5 ohms. Again this internal resistance, how much is there here? The 0.5 ohms. So question number 45. If the external resistance is equal to the internal resistance of a cell of EMF E, the potential difference its terminal is. So what is say here? The if the external resistance is equal to the internal resistance and the battery of EMF is given by the E, then what is the potential difference? What is the potential difference? Again the using of the formula, the current is equal to EMF by total resistance. The capital R plus small r. Here say the small r is equal to also capital R. And from Ohm's law, V is equal to I into R. Then I is equal to what we can write here? The V by R, because of we can find out the potential difference. Now we can write here the V by R is equal to E by how much is the R, and the internal resistance is also R. This is equal to V by R is equal to E by 2 into R. R gets cancelled. This potential difference is equal to EMF by 2. So next question number 46. Question number 46. 4 cells, each of EMF 2 volts and internal resistance 1 ohm are connected in parallel with an external resistance 6 ohms. The current in the external resistance. See how many cells are is given by the 4 cells. The first one, second one, third one, fourth one. These 4 cells are connected in parallel. What is it? This is 4 cells are connected in a parallel and meet at the one point, and is connected to the external resistance. External resistance. Now external resistance is given by the 6 ohm. And each of them, the EMF is given by the 2 volts, 2 volts, 2 volts, the 2 volts and 2 volts. Then find out the current in a circuit. What we can find the current in a circuit. We know the formula. The cells are connected in parallel. The cells are connected in parallel. Parallel cell of EMF or the parallel cell of current. Current I is equal to the total EMF by external resistance plus N by R, R by N. Internal resistance by number of cells. Internal resistance by number of cells. Then we can write here the I is equal to EMF. E is equal to how much is given? The each cell having the 2 volts, because of in parallel combination the potential difference will be same. External resistance how much is 6 plus internal resistance. The internal resistance each having given by the small r is equal to 1 ohm. Then we can the 1 by number of cells. How many? 1, 2, 3, 4 cells. Take here the LCM. 2 by 6 plus. 2 by 6 plus. And next here directly LCM. 24 plus 1 by 4. 24 plus 1 by 4. Then we can write the denominator of the numerator 2 into 4 8 divided by 24 plus 1 25. Then we have the calculation. This is the getting 0.32 ampere of the current can be flowing in a circuit.